Hello, everyone. Welcome to another Wolfram Language Design Review, again about our friend Tabular. Um, let's see, where are we? What are we looking at today?
So we have two main topics. The first one is how to distinguish element-wise operations from column-wise operations.
I thought we had this idea of element-wise, the
Um,
element-wise wrapper.
well, that's for element-wise operations. So we suggested column-wise to make functions like transform columns that operate on elements to work on columns directly. And you had suggested an alternative called whole tabular. If you open the section two ideas, you will see there the two ideas. So the previous section is just motivation for why do we really need this double mode of operation. So there you have transform missing anomalies, things that naturally work on columns as a whole.
Okay, so there are things that work on columns, but how does that, what is the element-wise mechanism in those cases?
So transform columns naturally works element-wise. So it goes row by row and performs operations.
Yeah.
And so if you see the first example that you have on the top, you see a case in which we want to, together with the hash call, we want to do a min of hash call. So that requires getting the whole column. The previous line, the first one, the first line of code.
Yeah.
Okay, insert columns.
So that's how we would do it right now, but we want something nicer than that.
Yeah, we want the above transform columns to work.
Okay, so wait a minute. Insert columns is, I see, it's operating on the whole tabular there. Because if I said hash call, I would simply get a single element of that column. Is that correct?
Correct.
Okay, and it is the case that most of the time you do want a single element. Is that true?
I would say yes. That's why transform columns works row by row, addressing individual elements.
Okay, but so this wouldn't work, right?
Exactly. It does not work now.
Right.
Right.
So the question is, how do we support something like that?
Right. So I mean, one possibility there would be something, but I don't know whether this semantically can work, whole column or something of call. I don't know if that can work.
Well, that's what we called whole tab. You had it as whole tabular before, and that's what we have below in the whole tabular thing.
Right.
And I've implemented that to sort of work.
But wait a minute. In this case, then what would it look like? Whole tabular of quotes call or what?
Quotes call.
Yes. It would be whole tabular of pound call or quote call. Yeah.
So okay, so the concept here would be this becomes whole tabular of quotes call here.
Yep. Yep.
I think it would make more sense to call it whole column, since it is always a column, isn't it?
Yeah, fine. I mean, the name is not, we'll figure out the name, but if it's the right concept.
So is there a reason why it should be a function like this and not just a symbol that's effectively set with block?
What would the symbol look like? Oh, the symbol would just be. So is it the case that if I say tab of quotes call, no, I have to say tab of all comma quotes call.
Right.
Right.
Exactly. So it's like that insert columns is awkward for the very reason you have to use the all.
Is there any object which can be indexed by a pure single subvalue? Is there any object we can construct from a tabular which is indexable as getting out columns with a single subvalue?
I don't understand what you mean.
So given that tab is a tabular,
right?
Okay, what is a decoration decorator of tab such that this then works. Oops.
be transpose, but I mean, yeah.
Would transpose work for that?
But I feel like just writing all would
Yeah.
be easier than whatever this is.
No, I know.
Yeah.
But I'm trying to understand that if in your symbol suggestion, Christopher, that symbol should be bound to an object that has the property that its subvalue gives you the columns.
I feel like that's just that. I feel like that would be probably more confusing than it's worth. Like you know how to deal with a tabular. You don't necessarily know how to deal with some weird transposed funky tabular, right?
Well, that's a little bit what we're proposing in the column-wise thing, but it's more global than just a single argument.
So maybe just a more general question though about the need for this. So like in the example written here, you don't really need a construct like this because you would just refer to tab again inside the function, right? But are there situations where that's for some reason difficult?
You're right. I think.
Well, the problem, yeah. So you could refer to tab inside of the function, but suppose you're evaluating that function. Okay, and that this comes to a fundamental issue. So you're doing it row by row. So inside a function, tab is unevaluated, right? Because function is hold all.
Okay.
So we would have to evaluate mean of tab of blah for every single row, because inside, without processing the function first, we'd have to evaluate that mean every single row.
But aren't you going to have to do that for? Oh,
Well, you could
is
probably
the point
count-
here
Well,
just that
that is a problem with the
magical
whole tabular.
compilation?
That's a problem with the whole tabular
Yeah.
design. That's an advantage of the column-wise design that.
Okay, well, let's look at that.
we're
But in this
suggesting
particular
here.
case, you could certainly cache this. Right? In other words, if you ask
Well,
for a
it's-
whole column of col, it's going to return some kind of tabular column object,
Yes.
right? And you could then cache that.
I mean, it seems like it's less a question of whether you can cache it and more of
Well,
is
we'd
the
have to
code
cache
sort of
mean of that
analyzable
thing.
enough?
Yeah. So it's
Right. Like yeah.
So the way I've implemented it is as described below. So basically, first it's a lexical thing. It has to be lexically in the function. So I do a replace all. And so it actually I'm inserting the column into the function expression in place of the whole tabular of quote call.
Why does that help you? You still have to reevaluate mean.
Well, right, but in many for functions like mean, we can figure out, oh, that's mean of a tabular column. We can evaluate it and be done.
Okay, so you're proposing to do some lexical gymnastics in that case.
Yeah, that's how Jose and I understood. I wasn't in some of the meetings where you discussed this, so that's how Jose and I.
All right, let's take a look at the column-wise idea.
Okay.
Okay, I think we understand this idea, and this idea has that, fairly major but not devastating downside.
Right. It's a downside. Okay, so column-wise is a special case. Okay, so we say key goes to column-wise around the F, and then what we do is we interpret the hash arguments differently. So it's basically doing F of transpose of the list of associations, so we're transposing it. So we're getting the association of columns instead of a list of associations for the row elements. And that's exactly what we already do in reduced tabular. So it's saying we want and transform columns, similar semantics to reduce tabular.
Well, essentially what you're saying then inside that column-wise, you would have an element-wise. Is that correct? So if I were to write your thing, if I were to say column-wise of hash col, no, of element-wise, what would you actually write there?
Well, in that case, you don't need to write it because it's listable, so it just works.
Rob has examples below with
There are
greater.
examples below. So look at some of the examples, and I think you'll see how they work. And I start with that mean case, simple.
And you should be able to evaluate this in today's prototype.
Okay. Did I need to evaluate the initialization cells in this notebook or not?
No.
These icons are still not fixed, right?
Yeah.
No.
Well,
What's
we haven't
happening
had
now?
a discussion about them, so
So here the column-wise works super nice because it's listable. But there is
Try
the
to
next
understand this.
example.
Wait a minute. Because I see. So this is replacing the whole column.
Yeah.
Yeah.
So when you see high, you're getting a whole column. Anywhere you see high, pound high.
Yeah, I see.
And that's again what we do in reduced tabular already. So it's not okay. So now
God.
here, yeah, right, exactly. That's how we'd have to use the element wise.
Oh my gosh, that's pretty horrifying.
But again, there's no issue in this case of having to reevaluate the mean because it's done once.
Basically, what we're saying here is, okay, in reduced tabular, okay, in transform missing, the meaning of quotes blah is a whole column. In transform columns, this is a row-wise transforming of columns by default. Am I making sense?
Yes.
I think it's going to be pretty confusing. It's going to be reminiscent of the crazy up evaluation, down evaluation of data set to have these functions. I mean, this is really a row-wise transform columns. As opposed to a whole column transforming of columns. Am I right? I mean, in other words,
yes, you're right. The column wise is saying do it on whole columns versus doing it.
Right, but so one of the questions, which I think we also addressed last time, is let's say there are two cases, row-wise and column-wise. Okay. Are people going to want to mix and match those in a single operation on a tabular, or are they going to be happy just doing just doing one operation that is the row-wise one and another operation that's the column-wise one?
Yeah. That's a reasonable question. Since we have operator forms for these, maybe we could have, I hadn't thought of a separate command which has this different semantics.
Right. I mean, I'm not sure if that's the right thing. I think, you're thinking about I'm transforming columns.
Another way to think about the mixed case is that one could obviously use a block or a width outside, compute the thing that you want to compute column-wise, and then use the row-wise, or vice versa.
Yeah.
Well, I'm sorry. Say that again, Roger.
I'm just saying that in terms of what's a workaround today, a workaround today would be that you use a block or a width outside, and you compute the mean for a column, give it a name, and then you do the inner operations, like say transform columns, because then that mean is already computed, and it's just a scalar. It gets from its environment, the block environment or the width environment.
But people don't know how to use width to put them in
Yes,
functions.
they do. Many people do. But I mean,
Okay.
I think that's not.
Right.
Look, this is not a winner, in my opinion. That's pretty obscure. It requires sort of a higher order function modification, et cetera, et cetera, et cetera. I'm going to
Right,
change
but
that.
having
to
a
say-
separate function won't change that, right?
I know. It doesn't really help.
No, it doesn't help.
I mean, reading wise, this seems to me to read the best.
Yes, I agree. In that case, it does read better.
What are the problems with this? Here's a
Okay, well-
question. Here's a question.
Mhm.
What about the possibility of saying here, just saying something like this? Could we allow things like this, where you do a whole column transformation here? Like for example, we say here, let's imagine we do this. Is that crazy?
No, that's not
It-
crazy. I'm not sure we even need the, maybe within the whole column thing, maybe the pound. I mean, that's an alternate to my column wise, right? It's saying the result comes from thinking of it as whole columns.
Right. But this allows you, I mean, I don't know. I mean, you could say table of 0, comma, whatever it is. I mean, it doesn't. How do you get, without some kind of supplied mechanism, how do you know, like, the number of elements in the columns? Or you can say length of whole column in principle.
Yes, right.
I'm kind of liking the whole column idea. How does it work in other functions? I mean, if I saw this in a piece of code, I would understand what it meant. Okay, how messy is the lexical stuff?
Well, the lexical replacement is easy. I mean, it's just it's a simple, super simple C function that, if it's actually, if it gives one column, it works. And if it doesn't, it's going to give a message saying that's not really a column. We can't use it. So the lexical stuff is easy. The stuff that's hard is how do we know when to evaluate that thing one time or multiple times?
Why would you ever evaluate it multiple times? By the way, what happens when there's grouping here? What happens if I want to say, I mean, you could imagine a similar syntax where instead of whole column, you say something like, maybe this is crazy, where you say something like whole group, and then you have the grouping thing.
Yeah. And that's, I had one idea where we put the grouping as an argument to transform columns, and then it did things grouped in some sense like reduced tabular does. If we have a group, we can do a grouping for each transformation, but does each argument in that thing have a separate grouping? That's going to become very, very complicated. But there is lots of applications for having grouping in things like mean, because you might, like in the penguin thing, you might want to group by species or something.
Right. Well, here, if whole column had a second argument, for example, then that second argument could be the grouping criteria. So you could say group by species and by fluffiness here. Would that make any sense? So in other words,
yes, that could be done.
okay. How does it relate to the other grouping stuff that we're doing? So in tabular reduce. Okay. How does this, wait a minute, tabular reduce takes whole columns and crunches them to single numbers. Is that a true statement?
That's right, typically, or yes.
To give an object which is what? I mean, is it a tabular at the end of it?
Yes, it's a tabular with the so each row in the result reduced tabular comes from a group. So you know, if your grouping finds 10 different groups, then you're going to have 10 rows in the tabular, one for each group. I mean, the transform columns becomes complicated because, okay, so I say mean column of high. Yeah, and we can do that particular thing and get the scalar, but that's only going to work for things that come out to be typically going to work for things that come out to be scalars.
Okay, but hold on. So having looked through all of this, is it your opinion, if we did the whole column idea, other than implementation issues, do we think that that looks nice from a, I think this is a lose, all this stuff here.
But the element wise I agree isn't lovely, but I think the implementation for the whole column is huge. So suppose instead of mean, you're using a function defined by down values. And that we don't know if those down values might have side effects or not, or evaluate different things in different times. And in this transform missing, I've actually added something where there is a side effect. And so it has to evaluate it every time it goes through the loop.
Okay, hold on. You're saying, okay, look, I think it's perfectly decent to say, if you say whole column, it will be evaluated once, period, end of story. Sorry, we're done.
What is it then? What is it that gets evaluated? How do you decide what that is?
Okay.
See, that involves a function processing thing, which is non-trivial.
Well, the problem is that what you've got is an up value story, right? This is as if it's an up value, where because this whole tabular is affecting the evaluation of mean. In particular, it's making it get evaluated.
Yeah.
So essentially what has to happen here is that the whole column function has to infect everything outside. Okay, what is the criterion? Everything, for example, any numeric function is safe. True statement?
Yes.
What are the attributes of mean?
Oh, mean.
It's not numeric Q because right,
Yeah,
it doesn't
because it can be
doesn't
single.
produce a number when you give it a single number. You have to give it.
This is a question for the compiler team, probably. I mean, in other words, this is going to be a type analysis thing, because it's got to be whether the functions, given the types that the whole column is, are those functions, what is the criterion? Christopher, can you see what the criterion is here?
Not immediately.
Okay. Criterion for what?
For whether you
to
can
evaluate
spread the evaluation, how far you evaluate. Clearly, if you hit hash high, you can't evaluate that. See what I'm saying? So in other
I mean,
words,
they're basically just asking, what can you memorize?
yes, what can you memorize? What is safe
I think
to not
that's
have?
pretty non-trivial. Like,
Well,
yeah, arbitrary. I mean, it's basically it's like asking if a piece of code is deterministic, and in general, that's really hard to answer because oh well, if it's calling module, it's using the
Yeah,
module
right.
count, and then it might whatever.
but and I think something you've said before, Christopher, and I've tried to keep this. So I have this optimized evaluator, but I've tried to keep everything so that we have a normal evaluation mode, which is just the simple thing that just works with our language. And that's sort of how I came up with this column-wise thing. I know it's not ideal, but the semantics of that are quite simple. There's no extra processing that has to be done besides doing that initial transpose.
Mhm.
And I'm just leery of trying to say, so if I define a function which is little m mean as a down value and define it in some way, how could we possibly ever know that can be evaluated just
Well, worst
once?
case is we don't evaluate it. I mean, it's just an optimization.
Well, yeah, but you're talking about n squared. If somebody has a big tabular, that's dead in the water.
Right. I mean, I think the point is that it's often, I mean, look, if we can do magic optimizations, that's nice, but it's
Yeah.
also very useful if you can write things in a way where the optimizations are, you ask for them and they're visible and understandable
okay,
and not just
so-
sort of magical.
So look, here's a way we could certainly do it. Okay. If we said whole column here, and then outside this, I mean, okay, we could just do this, for example, or something like that.
Yeah, but is that really that much better than having the element wise?
Yes.
Okay.
Yes, it is. Because this is just somebody says, it runs slowly. The code assistant tells them stick in and evaluate. I mean, people have been familiar with the idea that you
Ooh.
sometimes have to do an evaluate from, for millions of years from plot and so on.
Wait, but that's a totally, I mean, evaluate only works on the first level in a hold all thing, right? Like this is a very different use of evaluate.
Yeah, it's
Well, okay. I mean, I admit.
I mean, I think if you wanted a construct like this, you could call it something, but you couldn't call it evaluate.
Well, I
Yeah.
mean,
And honestly, the way that we do this right now, I mean, this is something that people, you could already want this. And as I think was mentioned earlier, you could just use with.
yeah.
If you're going to write it explicitly like this.
But how could you use with? You can't use with on the mean of whole column because you don't even know what it is until, I mean, unless you're just doing the with, taking the original tabular object.
Yeah.
Let's look at this again for a minute. Okay, so the issue is with an outer wrapper that tells you when, it tells you this is a thing that can be evaluated now. Okay, where the subtree inside the function is a evaluate it now subtree. So the issue is, okay, what I'm looking for is this particular piece of craziness.
Isn't it actually, I mean, implementation wise is not how you want to do it, but isn't this basically once?
It is. Is this semantically insane?
yes.
Because
Okay, so how do you describe the semantics of how it works? I mean, is there a simple
processes
normal
column
way?
wises first, and in the column wise, it's taking the meaning of the association it's giving the column wise is one which has whole columns. Then having evaluated the column wise pieces, it goes through and does the others, in which case the association is done row by row.
I see. So you're using column-wise, sort of like your tabular evaluate, the thing
Yep.
that tells it to evaluate. That
Right.
that
But
yep. I see what you're saying now. I understand it. So it's a two-stage evaluation.
that's correct.
I honestly, without trying something, I can't tell you whether it's insane or not. It probably is not completely insane. Yeah, column evaluate. And then so it processes all the column evaluate things first and substitutes the columns in there and evaluates that. And then
I mean, it'd be nice to use column-wise, but I think it has a semantic so semantically different from element-wise, isn't it?
yeah, it's semantically different from element-wise.
After all this discussion, I'm wondering whether to go back to your original suggestion, Stephen, of a separate function, some sort of transform whole columns.
Oh, the problem with
just
column
get them.
evaluate is what if column evaluate is something like transform missing that gives an entire column? How do you compare that with the greater than? Then high is an element, you have a list, and greater just returns unevaluated, for example. So that's why that doesn't work.
I see, that doesn't work because
Yeah. it might return a list or a whole column. So this would work for scalars, but only for scalars.
Well, wait a minute. How does this work? How does the whole column thing work for vectors? I mean, it's not going to work either. This is never going to thread. It's not the nature of greater thans to thread.
Right.
Exactly. I don't agree with you. I don't agree that this is what you can do if you really want the threaded version of this. Yeah, then if you want the threaded version, you're going to have to put it inside a column evaluate and do the thread. There's no alternative. I mean, then this becomes really no alternative but to say, if hash greater than
So in essence, a single column evaluate around inside and in the main part of the body is exactly what I'm saying column wise is. And so you're just adding possibilities of doing it at additional levels.
I'm confused by that statement.
Okay, well, suppose I just do column evaluate around that whole element wise if thing. That's exactly, I'm saying, I'm evaluating that on the columns.
Yes. I mean, I don't understand quite. I mean, if we say here, transform columns, temps, blah, 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 hot arrow, and now we say column evaluate, this is a function. Okay, the right-hand side here. I'm okay. Go on. What were you saying? I'm got myself confused here.
Well, actually, I think I might have been incorrect too. I've gotten myself confused as well, Stephen. So you're not alone. The problem is if we do, so suppose something in a column evaluate returns an entire column, which is a slightly different problem. Okay. How do we handle the mapping over that thing that returns an entire column?
Well, there's listability, and if there isn't, you have to do something because it's going to return. I mean, this whole column idea which has the possibility of a grouping as well. Then row by row, it returns, either the whole column or the group that's relevant. Oh boy.
Yeah, I mean, it's
I mean, unfortunately, from the outside with, you can't do things that involve groups. At least not easily, I think.
no.
Well, I have to say, this whole column thing seems to me, I mean, given that there's got to be some awkwardness somewhere.
Well, I mean, I will mention that element-wise looks horrible, but the much more common case is you'll be using listable commands like that mean thing, or
I know,
things
but
that
it's going to be
evaluate to
so
a whole
ugly.
column.
Okay, what would
But
happen?
I don't think that's the common case.
The column evaluate, which then also allows grouping.
Yep.
And column evaluate returns whatever it returns, which could be a list, it could be or it could be a single element, depending on what you have in there.
Yeah.
That, to me, is the least outrageous of the things we've seen here. And I like the neutrality of column evaluate, where its second argument is grouping information.
Yep. That would solve one problem. I think
I also like the fact that it has the word evaluate in it, because it suggests that you should be thinking about an evaluation semantics here.
Mhm.
Okay.
I can
that will be
try
my
and implement something along those
Yeah.
lines, Stephen, and we can
Okay.
bring this back up again, and we can
Okay.
compare and
All right.
contrast. How does
All
it
right.
do?
What are we doing next? What are we looking at next?
The next thing was the binning and the number categorization. I mean, these are just more examples of the same thing, but this is where you want to transform, you want to get a whole column out of a transformation.
Okay, so that's okay. So we should try column evaluate and see how it does for all these things. Make sense?
I will give it a try. Yeah, I think it's the sort of thing you have to try to see where the corner cases are and what works and what doesn't. And I'm happy to try things. So
sorry, can I mention again the possibility of a separate function? Because reduce tabular and insert columns only work with columns. It's the idea that we want transform columns to work simultaneously with row-wise and column-wise that is generating the problem. So perhaps having a separate function is a simpler solution.
Insert columns, though, takes, its hash foo is a row-wise hash foo, is it not? You're creating a column, not from whole columns, but from rows in columns. Isn't that correct?
The right-hand side is a column, not a function, right?
yeah, and insert columns, the right-hand side is something that you take a list and you convert it into a column.
So we have the functional notation in transform columns and reduce tabular. And construct columns.
Yeah.
Sorry, I was confused. In construct columns is the one that is row-wise, like transform columns, right?
Exactly. Both of those are row-wise. Yeah.
I mean, I think it's too bizarre to have a row transform columns.
Mm-hmm.
I don't even understand the name.
I mean, it's a
how to
row-wise
parse it.
operation.
What's that?
It's a row-wise operation. Hash
Yeah.
foo means the row element, the element, separate elements on each row.
Yeah.
Oh, so this is renaming what we're currently calling transform column.
Yeah, I mean, the name would be transform columns by row, but that's horrible.
But following the name whole columns, we could have construct columns and construct whole columns.
I see.
I see.
Whole
That's
columns.
an interesting idea. Yep.
Well, it's semantically simple.
Yep. It's super simple. Yep. And actually, the transform whole columns, if we wanted to, I don't think we should try this first version, but it could take a grouping argument, and to be transforming the whole columns by group effectively, which is actually a really interesting idea. But
whole columns, then. The question is, right, this is mapped over groups then. Whole columns wouldn't actually be whole.
right. That's true. It wouldn't be whole then. So that's not a good name for that, but it's a possibility with a different
Well,
Well,
name.
you're
what
still
other names?
transforming the whole column. You're just, slicing it up a bit first.
Yeah, you are transforming the whole column in steps, but not all at once. But yeah. I maybe, the transform whole columns, the different, and but construct whole column sounds a bit weird. So,
What's wrong with construct whole columns?
well, I mean, construct column constructs entire columns as well. But yeah, it's not wrong. It's just a little bit weird.
In a sense, insert columns is an insert whole columns.
Yeah.
I mean, the alternative is row transform columns and transform columns.
Yeah, I think the transform whole columns is much better than row transform columns.
Yeah, I don't think that row transform columns makes any sense.
I mean, the point is emphasizing it's a row-wise operation.
I mean, once that was explained to me, I sort of got it, but I still don't.
Okay, the problem is that insert columns then kind of has to be insert whole columns. Does it not? Otherwise, it's very confusing.
Yes, I think you're right. Insert columns.
What are the other functions that are related to this?
Those are the ones.
What
That's
about
it.
delete columns?
Yeah, it
Well,
does
we could.
delete whole columns, but I think that's getting,
Well, the deletion operation can be thought of as element-wise too. So I mean, it doesn't matter whether we delete the whole column or element by element.
That's true.
good point. Yeah.
It's like when we say call goes to um, nothing. That removes a column, even though it seems to be an element-wise operation.
Okay. What does Roger think? What does Christopher think?
Well, I like this semantically simpler approach to things. Still a little bit dicey about naming, but I think we can come up with maybe better naming.
But the issue is you're going to bank deciding I'm doing a whole column operation or I'm doing an element, a row-wise operation.
Yep. Yep.
Yeah. But
And this might, I think it will also help us having these two different commands, you know, emphasize the difference in semantics between reduced tabular and our transform columns. We have sort of a bridge between the two, which is the whole.
So actually, when we started this whole thing, we had these two. I forgot what they were called.
No, we had row map, which was transform columns basically, but we also had a column map which was different. I think this design is much better than the column map, and it's
Okay.
you know, it's Carlo can implement it for our virtual backend too.
Okay. All right. Well, then I think this is provisionally what we should go with.
Okay. I will do this. I'll also take a little bit of look at the column evaluate thing, but I won't spend a lot of time on it.
Okay.
Just to be thorough.
Okay. Let's go on to the categorization stuff. So we last time we thought binning was a better term.
Yeah, and I tried to think. So what I'm doing is I'm showing you what's different between this and bin lists, and I think bin is a really good name, but I couldn't come up with a good name including binning, so I just left the names the same and demonstrated what we can do now.
Okay. So I don't understand this. What is this?
Don't worry about so right now the functions, they're limited at a low level. They only work for tabular column, but I think this should be a general thing that works for a list of numbers.
Yeah.
Okay. So sorry about the extra, and the endpoints in right is to make it consistent with bin lists, because I got the default differently for whatever reason.
So let's remind ourselves, bin lists, if I give it random integer 100, 100, 10. Right. Okay.
Yeah, that's bins of width 10.
Okay, now what would number categorize like to use?
It can use the same sort of, but I think a nice one is to have, you know, bins of equal length, or n bins of equal length.
Yeah, wait, what is binless is a little inconsistent with histogram and maybe even bin counts, isn't it? Because histogram, when you say just 10, it means 10 bins approximately,
Right.
or like a
Yeah,
list
and
10 is bins
that's how we
10.
set this up to work. And so that's why I use that strange range of 3/4 argument, is to make it consistent with a case that we could compare it to bin lists for, you know, and getting exactly the same results. But
okay, so what we've got to do here is, I mean, it's kind of like, I don't know what the right term is, but it's kind of like number binning
Yep.
Okay. Now, but what you've defined here is other kinds of binning as well. And we've talked about this categorization function, right? Which is analogous to the
and I set up a prototype for that. Unfortunately, it won't work in your prototype, but I did set up an idea of a prototype for that. But the thing that's important for tabular versus bin, so bin lists, is effectively doing a group by. It's grouping by whatever bin it goes in, right? And for tabular, we want something that gets the categories but doesn't necessarily do the group by yet, because we want to do the group by for the whole tabular. And so
how are you going to actually represent the results of a? So where is this going to go? This is going to go in a transform columns.
It's going to go, typically in a transform whole columns.
Yeah.
Precisely.
But then how is it going to return its results?
Well, look at the tab table I put above. I used an insert a little farther up in the notebook. Farther up. Look at that tabular. So those are the numbers, and that's the result. So the Q is the result, and that's a symbolic representation of the interval is a category. Those are strings, and we can decide what the symbolic representation, but each number has a category that it goes in.
Okay. All right. Okay, fine.
And that's absolutely key for uses in tabular, is that you have
so I mean, the function that we could get, which isn't bin lists, is a thing that just goes through the list here.
Yep.
Okay. And essentially is I mean, how am I going to do this? I'm going to say hash, comma, I don't know, I'll just make it a constant thing, right? Like that.
Yeah. Yes.
Yep. Well, and that's what I set up with that number categorize function. I called it that, which is not a great name. And it gives, so given a, you set up the data based on the numbers in the list, and then you can categorize any number based on those categories.
Okay, but that's a different thing. I mean, in other words, the function itself is, I'm a little bit confused here. Is it making a categorization function, or is it returning this object here?
I set it up so you can make a categorization function. But the categorization function either returns a category or it returns a tabular column with categories.
Okay, so I mean, the examples are classify and nearest and so on, right?
Mm-hmm. Right.
So this is saying, so I mean, in this case, it would be like a categorize.
Yep.
And then there's the data, comma, the spec, and then it could just be an X, in which case it would just do it, or it could return, or this would be equivalent to that.
Right.
Correct?
Yes. Yes.
Okay.
Mm-hmm.
So what will be involved in, so categorize versus classify. So classify is a machine learning type thing.
And it's example driven.
Right.
It's not a spec per se. It's sort
Yep.
of.
Yeah.
So classify returns a classifier function. What? Oh.
I think you need to give it rules.
Whatever. Anyway, whatever I can do predict, so it'll make a predictor function. Okay. So this would be a categorizer function or categorization function. And
But
I mean,
but I
go ahead.
think it's a little bit different than learning from examples, in the sense that the sort of the symbolic specification language for dates and numbers and strings and categories is a little different.
Sure, but let's see what that specification language is.
Okay.
But do you think it's different at this level, or you think it's different in terms of how the spec works?
How the spec works. Because when you talk about strings, you might want to be able to have patterns, string
Oh yeah,
patterns.
I'm not worried about. Okay, let's look at the spec, and the question is whether categorize is capable of being a single function, or whether it has to be different for different. Whether you have to have different.
Right. Yeah.
Okay.
And we couldn't make it work. I mean, it's just we tried, and it's like the way you talk.
I started down that line because I found I find the bin list thing vastly confusing. You have to look, you have the right number of lists, and then you get this and that. And I put in, like an association type of thing, like, width goes to width, or, number of bins goes to the number of bins. I mean, actually using association type things to indicate what you're getting versus having this sort of arcane language with various nested lists. And that could generalize to the other cases as well.
Yeah, but of course it can. But are you getting one function that's then really complicated as opposed to a few simpler ones?
Okay, but here's another issue. What if the data is a mixed thing? That's pairs of a number. For example, it might be penguin species and fluffiness, and you want to categorize those as being zooable or not.
But then I would use transform columns. That's a custom thing. I don't think we should try to parameterize all possible combinations of things.
Okay, well, let's see what the argument, what the specifications are here. I don't understand these. Where's the stuff with where is the proposal for the different kinds of categorizers?
They're in the documentation.
They're in the documentation. There's a number categorize and a date categorize.
And here's a reason why maybe categorize is not a good name, because we want the category categorized.
Yeah.
Because you might want to reduce the number of categories,
Sure. So let me see what I would imagine. I mean, right. So, I mean, we've got categorized by ranges of numbers, by what am I saying? By sequential, by adjacent. What do I mean? By ranges that don't have holes in them. What do you call that?
Subdivision or partition. Subdivision
Oh.
or partition.
You mean intervals?
Yeah, okay, but I mean by coherent intervals, so to speak.
Or
I mean,
adjacent intervals?
Okay, I'm glad that there isn't an obvious name because I wasn't thinking of it. By ranges, basically, categorized by ranges.
Yes.
By sort of
I mean, there's a difference between domain and range. So when you do it by range, you want to do it by quantile, just what I'm saying, by distribution of values.
Right.
If you only know
by ranges, i.e., it could be literal values or equal bins, for example,
Yep.
or it could be quantiles. Okay.
Yep.
there's also just categorize by categories, basically by sets. So you might want to say, e.g., all mammals in one bin, birds in another type thing. Does that make sense? So, for example, for us, if they were entities, or e.g., cities by country,
Right.
let's look at what that looks like.
So that's a good example because that's kind of hierarchy. Yeah.
Mhm.
Actually, another thing, categorization, I mean, e.g., locations by country.
Yes.
So in other words, what's in the data is a geoposition, but you just want to say what country it's in.
Mm-hmm. Mm-hmm.
Although, I mean, how would you do that right now? How do you do that? You would say geo-identify, if I'm not mistaken. Is that right?
Yeah, I think so.
What is this? What is all this?
This is something that entities do now, downloading metadata.
But why is that happening? Why is it taking so long? Okay. So that's an example of a categorization.
Yep.
I mean, another one would be, are you in the set ABC or the set XYZ? Now, what about for dates? That's often categorized by granularity. Is that true?
Yes. But you can also have kind of multiple ones. Let's say you have day and month, maybe year, maybe quarter.
Yeah. What about that?
Right. I mean, I think it's I think you're much more likely to categorize dates by span, like what year are they in?
But
Or is
that's
that what you mean by?
granularity, essentially, but by a granular level, by
Oh,
a
I see.
granular element.
Yep.
Okay. Which is what I mean in let me see. What other things work like that? I mean, dates, unlike numbers, which don't have named precision levels, dates do.
Exactly. I mean, the closest thing would be integers versus reals, something like that.
Mm-hmm. Okay, that's a good example there. That's a good example. What other things? So
the other
another
thing
one
for
would be
categorize numbers is to use sort of a log transformed, which is kind of like addressing what granularity in a way.
Well, yes, it's like decibels or something, which is a log
Right.
scale.
Yeah.
Or the Richter scale.
I see. So that's essentially log, log bins.
Yes.
Mm-hmm.
Okay, what else? And you got quantiles there. Okay. So I mean, one kind of thing here. I mean, it seems awfully weird to use such a short name. Bin by month. I mean, in other words, if I said categorize and then I had a list of dates, and I just say by month, and what comes out are those dates granularized for a month. Is that what you imagine? Yes?
That's not what we were imagining.
Well, what were you imagining?
A new column that has the categories.
But these are the categories. The categories are dates with month granularity. See what I'm saying? That is the way of describing those categories. Now, if you say categorize numbers, then you need a different spec here.
Yes.
Right? And then those numbers might come out as a list of intervals or something like that. In other words, because what this is a representative, either a representative or a descriptor.
I don't think we have a
Wait,
super
wait,
good
wait.
way of.
Isn't this going to give us a pure function, or the categorize function, because you haven't given a data
Well, I don't
point?
know. I don't know. That's one possibility. Or it could actually just do it.
But well, right. But wouldn't it? Well, then the question is, what does right? Uh, hmm. Right, but you won't get the categories out from this, which I think is what categorize is wanting, right? It's going to give you the elements of the categories rather than the categories themselves.
What do you mean? I mean, the categories, you're saying, given a thing, what category is it in? This is not solving that problem.
Correct.
This is just telling you, this is binning, this is taking, it's like
I mean,
the
what you're
following.
what you're suggesting is giving me 100 numbers in 10 sublists, as
It's like
opposed
doing
to
this and then saying round of that. Right? That's effectively what it's doing. If I'm not mistaken. I mean, this is like labeling, like in a image processing function. We talked about this last time, where it returns the labels for every pixel.
right.
Yeah, but you still want the original picture. Like,
Right. Well, so the alternative is that in this case with dates, there's no really exciting thing that is the function, because the function is sort of a trivial regranularization function. Whereas if you want to do quantiles with numbers, you obviously have to process it based on the particular numbers you have.
yeah,
That makes sense?
yes.
I mean, honestly, the number of cases where it's data dependent seems small, but they may be important, like quantiles, for instance.
I mean, even the innocent looking specs where you say you want 10 bins, you need to kind of know something about everything.
Yes. Right. But
Well, so another question is how the categories are represented. So like, right, with numbers, it's obvious there'll be other numbers, but for like dates, will be a less granular date.
yes. But for
And
numbers,
for
it's not so
images,
obvious,
what
I
will it
think.
be?
What's that?
But for like images, what will it be? Suppose we have a way of binning images together. Like, what are you going to put as the category? How do you represent
Well, it
this
depends on
category of images?
what the binning is. I mean, let's take colors. Okay. How would we
Well, I mean,
categorize?
it's I'm not sure I agree with that statement. I mean, right, if what we're wanting to get out at the label, right, then it should be like July, not,
Just
2024, comma 7.
Okay. Okay.
I mean, right. I mean, if you know that what you want to do is group by month or whatever, that's just gather by, right? And then you project it back to get the, back to the original, the shape of the original list.
Okay, but I think it's an important thing to understand whether what we want is essentially things like July.
See, I think in a future release, we could have like a categorical object that knows about what the full list of categories are, if they're ordered, whether they're not or not, because it makes different things work, even for the list language and stuff, in the rest of the system. But I think that's hard to pull off now.
Okay, so you're saying that this will be a category object, date July, date, or maybe it's a month, date month or something.
So category object would probably say July, comma, list of all the months, or list of all the, all the months, and that they ordered in that order, January, February, whatever.
Well, or it can just name that it's a date month category object, and the particular one is July.
Yeah, if it knows. Okay, so here's where it comes into the curation. Let's say that date month is a curated scale, which it very well could be. Then the only thing you need to know is the name of it, right? And then the specific one that you have there, July.
Yeah. All right, I think I have to go to another meeting here, but we will continue this. We may miss this Thursday, but we'll push this to a different day. Okay, anything else here right now? Nope.
Yep.
Okay, see you all soon.
Bye.
Bye.
Bye.